Welcome to another AP Computer Science multiple choice practice video. In this video, we're going to be going over a few of these multiple choice questions, and let's go ahead and dive right in. So this first problem says, consider the following instance variable and method. So we have this array of ints, and we're given these preconditions that it doesn't contain any duplicates, and the elements are in ascending order. We're being passed in 3 parameters into this mystery method. A low, which is an int value such that it's between 0 and the length of the array, a high such that it's between low minus 1 and array.length, and then num, which is an int value. And so we're given this code, and you might notice it's recursive. It calls itself a couple of times. And we're being asked what is returned by the call mystery 0 array.length minus 1 num. So I'm not the type of person who can just look at code and super easily figure out what's going on. I'm a bit more of a look through an example and see what it does with the input code. So let's go ahead and do that. So let's say that our array is 0, 2, 5, let's say 7, 10. Okay, let's say that's what our array is, and we're being passed in 0 as our low, array.length minus 1 as our high. So that would be, if we have 5 elements in our array, this would be 4, and then num would be, let's just say this is going to be 6, for example. Okay, so we're calling mystery with 0, 4, and 6. So let's go ahead and figure out what this mystery code is doing by running through this implementation. So it says mid is equal to low plus high divided by 2. So mid is low plus high, so 0 plus 4 divided by 2. So that's going to be 2. It says if low is greater than high, so 0 is not greater than 4. So we're not going to go into this. You might notice this is a base case because we're returning a number. There's another base case down here. But let's see. Let's check our other conditions first. So it says if array at mid is less than num. So let's include our indices, index 0, 1, 2, 3, 4. So array at 2 would be 5. So we would be comparing 5 to num, which is our 6. This is true, so we're going to go ahead and do another recursive call and call mystery with our mid plus 1 as our low. So now we're calling mystery with mid plus 1. Our mid was 2, so this is now 3. High is still the same. It's still going to be 4, and then our num is still going to be 6. So now we run through that code again. So mid is going to be low plus high divided by 3. So 3 plus 4 divided by 2. We're going to be doing a little bit of integer division here. So you would anticipate this to be 3.5, but none of these are doubles. So we're actually just going to truncate the 3.5 to a 3. Is low greater than high? So right now our low is 3. Is low greater than 4? No, it is not. We don't go into this condition. We check the next condition, which is whether array at 3 is less than num. So array at 3 is 7. Is 7 less than 6? No, it is not. So we move on to the next case. Now we're checking whether array at 3, which is 7, is greater than num. So yeah, it actually would go into this condition. So now we're calling mystery once again with our mid minus 1 as our high. So our low stays the same. Our new high is mid minus 1, so that would be 2. And then our num stays the same. So now we have 3, 2, and 6 as our parameters. So let's run through the code again. So we get mid is equal to low plus high divided by 2. So 3 plus 2 divided by 2. 5 divided by 2, so 2.5, but then we truncate it to just 2. We check whether our low is greater than our high, so we have 3, is 3 greater than 2? Yes, it is. So now at this point, we're going to be returning our low, and that's going to go all the way back up. Remember, we called this recursively so many times, and since we reached the base condition, we're actually going to be returning it back up to the original call of mystery when we called it with 0 array.length minus 1 and num. The number that we returned was 3. So how do we know that we needed to return? The last call to mystery was when we had found that the array at the midpoint between low and high was greater than num, right? And then once we had found that there wasn't a mid in between low and high, once our low had become too large, then we returned our low. If we go through our answers, it's not going to be the number of elements in R that are equal to num. So if you look at this, there aren't 3 6s in this array, right? There's 0. So that wouldn't make any sense. The number of elements in R that are greater than num, this also wouldn't make sense. So we only have 1 and 2 elements, so this D would not work. The index of the middle element in R. So this one may seem promising to you, but once again, the index of the middle element would be 2, so this one wouldn't work either. So now we're left with the number of elements in R that are less than num and the number of elements in R that are less than or equal to num. For this specific array that I chose, it might be a little bit hard to see which of the two answers is right. So let's go ahead and try out another example where we actually do have an array that is equal to num. So let's make our array a little bit smaller. Let's make it like, let's make it look like this, okay? We're calling mystery 0, array.length -1, so 2, and then num. Let's keep our num the same to 6. So let's go ahead and implement it, and let's see what we get. So we're calling 0, 2, and 6. So our mid is going to be low plus high divided by 2. So that's going to be 0 plus 2 divided by 2. So that's going to be 1. Is low greater than high? Is 0 greater than 2? No, it is not. Move on to the next condition. Whether array at mid, so mid is 1, is less than, which is 6, whether that's less than num. No, it is not. We move on to the next condition. Is array at 1 greater than num? No, it is not. So we move on to the next condition, which is an else. And it gives us a helpful little comment here that this is when the element at index mid is equal to num. We just return mid. So at this point, we're returning 1. So we didn't even have any recursive calls in this one. We just returned mid, which was 1. So if we're choosing between the number of elements in an array that are less than num and the number of elements in an array that are less than or equal to num, I would say that the right answer here would be A, right? If the number we had returned from mystery was 2, then it would have been the number of elements in an array that are less than or equal to num, because it would have been 1 and 6. But since it was just the 1, since we returned 1, the answer is going to be A. Moving on to the next problem, so questions 11 and 12 refer to the following information. It says, consider the following instance variable nums in the method find longest with line numbers added for reference. This method is intended to find the longest consecutive block of the value target occurring in the array nums. However, find longest does not work as intended. It sounds like my code, am I right? For example, if the array nums contains these values, the call find longest 10 should return 3, the length of the longest consecutive block of 10s. And then we have our code here, and we have line numbers. Very helpful. So let's see what question 11 says. It says, the method find longest does not work as intended. Which of the following best describes the value returned by a call to find longest? So this is one of those problems where I would recommend not looking at the answers before you try to figure it out. So we can go ahead and we can just run it through this array that we have. Okay, so here is our array, and this should be returning 3, but let's go ahead and see what it actually will. So we're basically just running through this array, and we're saying that if the value is equal to target, we're going to increase our count. So our target for this is going to be 10. So starting at this first index, is 7 equal to 10? No, it is not. Is the length count greater than the max length? Well, we initialize both of these to 0, so 0 will not be greater than 0, so we're not going to be setting our max length, okay? Moving on to the next element, we've got 10. This is the target, so our length count is going to be 1. Same thing for the next number, so we increase that again. However, the next element is a 15, which is not equal to our target. So now we go into this else, and length count is greater than max length, so it's greater than 0. Our max length is now going to be 2. Okay. Hopefully you're starting to see an issue here. We're trying to find the longest consecutive block of the value target, and it seems like we just ended our consecutive block, but we're still keeping our length count to be the same. All right, so when we move on to the next 15, you'll notice our length count is still 2. Uh-oh. So at this point, we're comparing length count and max length again because we didn't find our target. Length count is not greater than max length, so we're going to move on to the next element. 15, once again, we're just comparing those two numbers we just did. Still not greater than the other. We're moving on to the next 15, same thing. Then we're moving on to this 10. Now we found another 10, we found the target, we're going to increase our length count. So now we're going to get 3. Next number, we found another 10, increase our length count, 4. Next 10, we found another number, another 10, we increase it, 5. Next number, 15. So now we're going into the else. We're saying, is 5 greater than 2? Yes, it is. So now we're setting our max length to 5. Move on to the next number, which is a 10. Increment our length count to be a 6. And then we move on to the next number, which is another 10. So we increment our length count again. We exit the loop. We're done with our array. Now we're checking whether length count is greater than max length again. So whether 7 is greater than 5. Yes, it is. So now our max length is 7, and we return our max length. Okay, so that seems a little bit fishy. If I was just looking at this by eye, I would say the longest consecutive block of 10s of our target, which is 10, would be a 3. But we said that that count was 7. And you might notice that we have suspiciously 7 10 within our array. To answer this problem, what we actually found was the number of occurrences of the value target in nums. We didn't find the longest consecutive block. Every single time we found that target, we incremented our count. It's not the length of the shortest consecutive block of the value target. This one is incorrect. If it was this, it would have been 2, I believe. Yeah. It's not the length of the array of nums. So there's 13 numbers, I think, if I counted correctly, and 13 does not equal 7, so this is not correct. It's not the length of the first consecutive block of the value target in nums. That would be that 2 again. It is also not the last block, which would also be 2. So the correct answer here is C. We got that by running through our array. If you're running low on time, you might not want to run through the whole array just to save yourself a little bit of time. I just did it just for peace of mind. After a little bit, hopefully you started to see a pattern. Let's move on to problem 12. So problem 12 is still talking about that same find longest method. It says, which of the following changes should be made so that the method find longest will work as intended? And then, so it's basically saying we should insert the statement len count equals 0 between some sort of line. So let's go back up to our code. So what were we doing incorrectly here? It was the fact that as soon as we finished a consecutive block, we weren't setting our length count back to 0, right? So this should have been 0 once we finished our consecutive block. So now we just need to figure out where to put that. So the options are, so let's take a look at our options. Our options are between lines 2 and 3, between lines 8 and 9, between 10 and 11, between 11 and 12, and between 12 and 13. I would say that between lines 2 and 3 would be wrong. So say, for example, we counted this first 10, so our length count is a 1. And then when we move on to the very next 10, what we're going to do is we're just going to set our length count back to 0. So we would be doing it way too early there. So I would say A would not be the right answer. We don't want it here. All right, let's move on to the next one, between lines 8 and 9. I think here we're also doing it a little bit too early. So if we had len count equal to 0, once we finished a consecutive block, so like once we got to this 15, we would be setting our len count equal to 0. So then we wouldn't be comparing, prior to line 8, our len count would have been 2, but then what we're doing is we're setting it equal to 0. So then when we compare len count to max length, we're not going to get that it's greater than 0. So we're not actually going to update our max length with the longest consecutive block we've seen so far. So I would say line 8 and 9 is also too early. Between line 10 and 11, this is going to be that same problem where we're setting it too early. So at this point, we would have been able to compare our len count and our max length. So we would have gone inside of the if statement, but then we still need to set our max length equal to the len count so that we can keep track of it throughout the loop. We basically would just have our max length equal to 0 all the time. So I would say 10 and 11 is incorrect as well. The next one is between lines 11 and 12. So that would be right after we set our max length equal to our len count. So right here. So this is good for if our len count had been greater than our max length. So say, for example, we were here and we set our max length. We went through, we compared, is 2 greater than 0? Yes, it is. So we execute this line of code, we update our max length to be 2, and then we update our len count to be 0 to start over at 0 so that we can count those consecutive blocks. But then what happens if the very next block that we look at is the same length? If it's 10 and 10, so our len count, we can kind of speed up the process, would be 2. So our len count is no longer greater than our max length. So we're not going to go inside of this if statement. We're not going to set our max length equal to our len count. That's fine. That's okay. But we're not going to start our len count back at 0. So say, for example, we had a 15 and then another 10. So we're going to get to that 15, but our len count is still going to be 2. So, and then when we get to this 10, we're going to increment our len count again. So I would say that this is also too early. This leaves us with between lines 12 and 13, and I would say that that is the correct answer for this problem. So that would be down here. So this is the correct place to be putting it, right here. The reason why is it's not too early, such that we're going to be clearing out our len count before we've set it equal to our max length, but it's also not within the if statement, such that we're not going to clear out our len count if our len count wasn't greater than max length. It's the perfect balance of waiting until we've done all the logic and not relying on some conditional that doesn't need to be true in order for our len count to be 0. It's at the end of the else statement, if we haven't found that target, at the end of all of our max len logic, we should be setting our len count equal to 0. So correct answer for problem 12 is E, and all of these other ones are incorrect. All right, moving on to the next problem. This says consider the following instance variable and method, and we've got another array of ints. It says numbers contains int values in no particular order. We have this mystery method, and we have to figure out what it does. So basically, we're looping through numbers backwards. If we find that the int at index k is less than the num that was passed in, then we return k, otherwise we return -1. So it says, which of the following best describes the contents of numbers after the following statement has been executed? And the statement is int m equals mystery of n. So I'm not gonna lie, I think that this question is worded pretty poorly. When I first read it, I had to think about it for a little bit before I actually understood what it was trying to get at. It describes the contents of numbers. When we run mystery of n and we get this int m back, we can derive a relationship between m, n, and numbers such that it matches up with one of the answers that we are provided with. I think it kind of helps if we run through an example first so that we can kind of find our grounding. Let's say that we have an array, say it's like 10, 4, 7, 8, for example. And let's say that the number that we're being passed in is equal to like 6, for example. I think it helps if everywhere you see num, you put an n. Okay, so you put an n here, an n here, and then the m, that's the value that's going to be returned from calling mystery of n. So basically, m is either going to be this k here or this -1 here, okay? I think that sort of helps you derive that relationship because it can be kind of hard to correlate m to k and n to num. So I think that's another kind of confusing part about this problem. So everywhere you see a num, replace that with an n. Everywhere you see a return, that should be m. So we're calling mystery with 6, and we're saying that numbers is this array here. So we're going to loop through this array backwards, starting at, if we have our 0, 1, 2, 3. We start our loop at k is equal to numbers.length -1. So the length is 4. 4 minus 1 is 3. So we're going to start at the last element in our array. We're going to make sure that k is greater than 0, and we're decrementing k each iteration of the loop. So we check whether numbers at k is less than n. So numbers at k would be numbers at k is equal to 8. So we want to check whether that's less than n, where n is that 6 that we passed in. It does not, so we decrement our k. So now k is 2. Now we're looking at this 7 here. 2 is still greater than or equal to 0, so it's still valid. So we check whether 7 is less than 6. No, it is not. We decrement our k again. We get that k is 1, also still greater than or equal to 0. So numbers at k is now 4. So 4 is actually less than 6. We would actually return k, which at this point is 1. So we would return 1. So for int m is equal to mystery of 6, given this array, we would say that m is equal to 1. What were we trying to find, and what process were we using for it? So I would say that the number that we're returning is the very first number within the array that is less than n. We can assume that every number after that index m that we returned, every single number was greater than or equal to num, or n, whichever you want to call it. How do I know that? Well, the only condition we were checking for is whether that number was less than n, or num. And at that point, we would be returning. Otherwise, we would keep going through the loop. So I would say that the correct answer here would be C. All values in positions m plus 1 through numbers.length minus 1 are greater than or equal to n. You can think of m. M is the index of the first number that is less than n, okay? So what that means is every single number ahead of m, so starting at m plus 1 all the way to the end of the array, is going to be greater than or equal to n. So let's go ahead and see why these other answers are wrong. All values in positions 0 through m are less than n. So since we are returning the very first instance of a number that's less than n, we don't actually know what is before that index. If you looked at our array, you would see that that's incorrect because the values from 0 through m would have been 0 to 1. So this here, so 10 and 4, and obviously 10 is not less than n, so that wouldn't have worked. The reason why is we didn't look at any value in the array before our m, so we don't know anything about what's before that. We could have had, our array could have been like 100, 1000, 15, something like this, but like we would not have known anything about that because we were going through our array backwards. So A is not correct. B is also incorrect. The reason why is it says that all values in positions m plus 1 through numbers.length minus 1 are less than n. This is not correct. So remember, for our example, the values in positions m plus 1 through numbers.length minus 1 are less than 1 would have been this 7 and this 8, and those numbers were not less than n. We returned the very first index that was less than n because we knew all the indices after that were greater than or equal to n. So B is also incorrect. D, the smallest value, is at position m. This is not correct. At position m, we have the very first number that is less than n. Another way that this answer could have been disproven is, say for example, our array had like a 1 here. Since we found the very first index from the back of the array such that the number at that index is less than n, there could have been countless other numbers before that number, but we just didn't know about it because we didn't make it all the way back there. It's not saying the smallest value. And the largest value that is smaller than n is at position m. This is also incorrect. So this answer is kind of assuming that we know what's in the entire array, but this is not true, right? So another way that we could disprove this answer is, say we had like a 5 here. Because we returned at the very first instance of a number that was less than n, we didn't know what was before. This is kind of like the last answer where we're making this assumption about what's before the number, before that index in the array, but we cannot make that assumption. So the correct answer here is C. Hopefully this helps you out with these APCS multiple choice problems. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.